In this video, I'm going to show you how to use force triangle method to find resultant of two concurrent forces. The figure on the right shows two concurrent forces P and Q acting at a point A of a rigid body. The magnitude of the two forces as well as the angle between them is given. We have to find resultant force R of these two forces. I'm sure you are familiar with the law of parallelogram as it is taught in high school physics. It is a graphical method, and as you can see in this figure, the two forces form the two adjacent sides of a parallelogram, and the resultant is the diagonal of the parallelogram. I'm not getting into the details of this method. Instead, I'll tell you about the force triangle method, the method which you would be using quite frequently in the engineering mechanics course. The force triangle method is a graphic cum analytical method because we first draw a rough sketch of a force triangle and then use trigonometry to determine the magnitude and direction of the resultant. So what is the procedure of constructing a force triangle? Well, it is fairly simple and straightforward. From point A, draw a vector AB in the direction of the force vector P, and from point B, draw another vector BC in the direction of the force vector Q so that the angle between the two vectors is the given angle theta. Note that the tail of vector Q is touching the tip of the vector P, and this is what is called as joining the vectors in a tip to tail fashion. Now join the points A and C to complete the triangle. The side AC represents the resultant vector R. You have to keep in mind that the force triangle that we have just drawn is just a sketch and it is not drawn to any scale. But some sense of proportion is to be maintained. What I mean is that if the force P is 100 newtons and the force Q is 50 newtons, then whatever length AB you choose, the length BC of vector Q should be roughly half of length AB. Okay, we have drawn the force triangle. What do we do next? Well, the answer is we use the triangle rules to find the magnitude and direction of the resultant. So here are the triangle rules. The first one is called the cosine rule and the second one is the sine rule. And note that these two rules are applicable to any triangle. In the triangle ABC, we know two sides, AB, which represents force P. We also know the side BC that represents force Q, and also the included angle beta, which is nothing but 180 minus theta, which is the angle between the two forces P and Q. We can apply the cosine rule to find the side AC because on the right hand side of the equation, we know all the variables. We can then apply the sine rule to find the angles alpha and gamma in order to find the direction of R. Well, this is the simple procedure of finding resultant of two forces. The question is, what do we do when we have three or more forces? Well, then instead of a force triangle, we have a force polygon. As you see in the slide, when you have a large number of forces, the resultant is a vectorial sum of all those forces. And as you can see in this figure, there are four concurrent forces acting at point A of the rigid body. Now, suppose the angle between the force F1 and F2 is alpha. We draw force vector F1 and from this point we draw the force F2, keeping the angle between them same as alpha. So this side of the triangle is sum of the forces F1 and F2. And if we have to add the next force, we extend this line, and if this angle is, let's say, beta, then we draw another vector at an angle of beta with respect to this line, so that this vector is the sum of the three vectors, and if we have to add another vector, we just extend this line and keep this angle equal to this angle, which is angle gamma. So from the starting point, that is the tail of the first vector, to the tip of the last vector is the resultant. And we have formed a polygon instead of a force triangle. This is a force polygon. But I would like to add here that this method is not so convenient when adding 3 or more forces. Instead, you will find that the method of summing the rectangular components is a better and more convenient method. And we shall be talking about this in our next video. So, thanks for watching and see you in the next video.